Okay, I decided to go ahead and add this application to the section on that involves the first derivative test and finding extrema. So let's go ahead and look at this example. It says, suppose the path of a projectile propelled at an angle theta is given by this formula here. And theta, of course, is between 0 and 90 degrees, or pi over 2. Y actually represents the height of the projectile. X represents the horizontal distance traveled. G is the acceleration due to gravity. V naught is the initial velocity, and H is the initial height. Well, let's go ahead and give you a few things. We can go ahead, for G, we can go ahead and use the constant negative 32 feet per second per second. For the initial velocity, we'll go ahead and assume the initial velocity is 24 feet per second, and we'll assume the initial height is 9 feet. Okay, and so what I want to know is what value of theta produces maximum horizontal distance. So an example of this could be maybe an Olympic athlete that's tossing some object like a javelin or a hammer or a shot put. And you'll notice that 9 feet might be where the height of where the item is released, and then the initial velocity is 24 feet per second. Okay, so to solve this, the problem is I've got really too many variables here. But what I can do is I can actually, since y is the height, if I set y equal to 0, that will actually give me a function that involves theta and x. And so right here would be the function. Now actually I left out an x squared right here. So there should be an x squared right there. Okay, now when you look at this, you can think of this as a quadratic equation because you've got x squared, you've got x, and you've got a constant. So the coefficient of x squared is minus secant squared theta over 36. The coefficient of x you can just say is tangent theta. And then the constant, of course, is 9. Now, if you apply the quadratic formula here, you'll get minus b, which is, of course, minus tangent, plus or minus the square root of b squared, so tangent squared, minus 4 times a times c. Now, notice here, and then all over 2a. Now, notice that 4 times 9 is 36, so that will cancel with this 36. So, basically, those terms, those factors cancel. And then I have minus a minus, which makes it a plus. So basically, in the radical, I'm just going to have tangent squared plus secant squared. Now, on bottom, 2 goes into 36, giving me 18. So I'm going to have minus secant squared over 18. Now, in the next step after this one, I'm just going to flip this over and multiply. So if I flip it over and multiply, then I get negative 18 over secant squared. Times all this. But secant squared is actually cosine squared. Okay? Now, what I'm going to do is I'm going to take that cosine squared and I'm going to break it up into cosine times cosine. So I'm going to leave one cosine out here, and then I'm going to distribute this cosine through the parentheses. Now, if I distribute this cosine through the parentheses, I get minus tangent theta times cosine theta. Now, if I distribute it inside the radical, it actually becomes cosine squared. So when I put it inside here, it becomes cosine squared times tangent squared and cosine squared times secant squared. Well, you can check this, but tangent squared times cosine squared is actually sine squared. And then secant squared and cosine squared are actually reciprocals of one another, so their product is just going to be 1. And then here, tangent theta times cosine theta is just sine theta. So basically, I've got it simplified down to a little bit simpler formula. All right, so now if I can find the derivative of x with respect to theta, so that's what I want to do next. I want to find the derivative of x with respect to theta. But this function down here is actually a pretty complicated function. I mean, I'd have to do the product rule with minus 18 cosine theta being u and all the stuff in the parentheses being v. But then even if I do that, what's in the parentheses involves a square root. So it's going to get pretty nasty if I try to differentiate this by hand. So what I did, I kind of cheated. I found an online utility, and I used that online utility to find the derivative. And when I found the online utility, it gave me the derivative was 18 times the quantity square root of sine squared theta plus 1 minus sine theta times sine theta square root of sine squared theta plus 1 plus cosine squared theta. And then all over this square root. Now, in order to find where theta maximizes x, we actually need to set this equal to 0. So we set this equal to 0. Now, again, I went ahead and just cheated here because, you know, when you get into real-world problems, many times you're going to rely on computer utilities. So what I did is I used a graphing utility here to actually solve this equation. So when I solved the equation, I actually got that theta was about 0.615 radians, and that converts to 35.3 degrees. So there's you a real-world application that was solved using technology. Now we'll move on to concavity.